So is that what science is? Just a collection of facts? No, of course. Facts are amazing, they're interesting, they're important, but that's not what science is. Science is a scientific method. It's a way of life, it's a way of thinking, it's a process that we go through to observe nature, collect data, collect information, and prove or disprove if something is true, factual, or just fiction or imagination. So science is a way for us to learn about nature. And of course in the process we discover a lot of interesting facts, but unfortunately in schools they push more learning so many boring facts instead of teaching the young how to discover. And the way that we discover about nature is a lot more interesting than the facts themselves sometimes. And it's a very, very amazing adventure that I'd like to share some of those experiences with you. So where do we do experiments? Where do scientists do experiments? Well, scientists do experiments in the lab, as you can see here. But the lab, this is a small lab. The lab can be much bigger. Here's a lab bordering between France and Switzerland. It's called the Large Hadron Collider. It's a huge, huge lab. This is one of the most complex machines ever built by man. It is so big that actually it's 27 kilometers in circumference. It's huge. Why is it so big? Because inside, under the ground, about 100 meters below the ground level, they have a tube that goes all the way around. So why is it called the Large Hadron Collider? Because they make protons travel almost at the speed of light in one direction, going in the tube that way, and then protons go in the opposite direction, also going that way. And then when they meet, when these two meet, when they collide, they shatter into pieces. I'll tell you more about that in a minute, but before that I want to tell you something that is amazing about this picture here. There are about 10,000 scientists from all over the world collaborating and cooperating to discover more about nature in this Large Hadron Collider. 10,000 from all over the world. From Korea, Japan, United States, Canada, Germany, France, China, India, so from all over the world. And that brings a point that I would like to impress you with about science. There is no such thing as Indian science or Chinese science or American science or German science. Science is the same. Science is exactly the same anywhere you go in the world. So it actually unites humanity. It unites us because we all speak the same language of science anywhere we live in the world. We could be wearing different clothes, eating different food, speaking different languages, come from totally different cultures, and yet when it comes to science, we're completely united. Speak the same language, think the same way, and we discover the same facts about the natural world, which are common for all of us. And so science is a very, very great uniting factor for humanity. Anyway, going back to this collision of particles, look at this. This is what happens when these particles collide. They shatter into millions of pieces. So there are 2,556 bunches of protons. A proton, if you remember from your school, atoms are made of electrons, protons, and neutrons. Protons are positively charged. The electrons go in orbit and they are negatively charged. And then neutrons are in the nucleus with the protons and they have no charge. Anyway, so they have 2,556 bunches of protons. Each bunch has 100 billion protons. And they have supercomputers at the LHC, the Large Hadron Collider, that process 600 million events per second. That's mind-boggling. That's why this is the most complex and sophisticated machine ever invented by man. It's fantastic, and it has helped us learn a lot about nature and a very, very tiny part of nature, the subatomic particles, meaning that particles smaller than an atom. So, where else do scientists do research? Well, we showed you the small lab, we showed you the big lab, and now I'm going to show you that scientists also can go out in nature, outside the lab, collect samples, and here they are in a riverside, just examining samples of water or animals or soil. So it doesn't have to be in a lab. Here's another example. Here's a scientist, a paleontologist or an archaeologist, will go and dig layers of earth to find and discover artifacts of humans or fossils of animals or plants or bacteria or insects that lived, maybe thousands or hundreds of thousands or millions or even billions of years ago, to discover what we can learn about living things and fossils of long time ago, of creatures that lived way before humans appeared on the planet. So here's another example. Here's someone collecting a sample from lava. Lava is the very hot melted rock that comes from a volcano when a volcano erupts. We call it lava. And he's collecting a sample. Of course, he has protective clothing, otherwise he'll be burned because it's very hot. So he collects the samples and runs away to the lab to analyze this sample. Well, here's a fantastic device that humanity has come up with in 1990, and I'm just so totally amazed by this device. It is called the Hubble telescope, named after an astronomer, Edwin Hubble. And this telescope is in space. How high up in space? 560 kilometers high up altitude. And it weighs 11 tons. And it's 13 meters long. It's as big as a school bus, slightly bigger than a school bus. This is a telescope. It's called Hubble telescope. We collect a huge amount of data and learn a tremendous amount of information about our universe because of that telescope. Why do we have to have a telescope above the Earth atmosphere? Because when you have telescopes on Earth, the atmosphere, the air, interferes with the light that comes from outer space. And it distorts the picture. It's not very clear. With Hubble telescope, there's no air up there, and so it brings stunning and amazing images of the universe. Here's some examples. Look, we call these the pillars of creation, and this is the part of the Eagle Nebula. This picture became so famous that you can find it on T-shirts, on coffee mugs, and all kinds of souvenirs. It's fantastic. And inside, the reason they call them pillars of creation is that inside this dust, cloud of dust, we call them nebula, inside that dust and gas is where stars are born. We call them stellar nurseries. That means places where stars are actually born. And as you can see, some stars are actually shining inside that. And this is another fantastic image taken by the Hubble telescope of this called the Helix Nebula, actually, a planetary nebula. It's a star that died, similar to our star. In the center, maybe you can't see it, in the center of the blue part is a tiny white shining part. That's the white dwarf. That's what's left of the star. The rest, all the dust and gas of this star was spilled out and ejected from that star into space to join other nebulae and become part of the other gas and dust in the nebula surrounding it. And here's another fantastic image of a nebula. This is called the Cat's Eye Nebula, and it's also another example of a star. You can see the white dwarf star, what's left of the star after it died and exploded. You can see in the center there also. These are the kinds of images that came from Hubble, and I really encourage you to go online to the NASA website and look at the fantastic and mind-blowing images that the Hubble telescope came up with. So where else can we do experiments? Well, look, humans have also collaborated from all over the world to build the International Space Station. This space station is in orbit around Earth, and a tremendous number of experiments, huge amount of research is being done in the space station by scientists from all over. And these astronaut scientists can actually be there for a long time. They can stay there for maybe 6 months or even longer at one time to do these experiments. What experiments? They do experiments in agriculture, how plants grow in space without gravity, in medicine, and on bacteria, on small tiny animals, and on physics, chemistry. All kinds of experiments are being done in the International Space Station. We've even gone farther than that. We have sent the Curiosity rover, and it runs on wheels, and this machine is actually conducting experiments on the surface of Mars. Mars is the planet behind Earth. We are the 3rd planet. Mars is the 4th planet after Earth. And this machine is actually analyzing the atmosphere of Mars and the soil and the rocks of Mars to find out their physical and chemical characteristics. So we have even gone farther than that. As you know, everybody's favorite planet is Saturn because it's gorgeous. It has these huge, big rings surrounding it. And the rings of Saturn is what makes it so gorgeous and fantastic. And Saturn is a huge planet, actually. It's the 2nd largest planet. The largest planet is Jupiter. Saturn is the 2nd largest. And it has about 62 or 64 moons. The Huygens probe actually was sent from the Cassini mission to land on the surface of Titan, one of the largest moon of Saturn. And a big surprise, they found lakes and rivers and even oceans of liquid. How can that be? Because Saturn is so far away from the sun, and the temperature is about minus 170 degrees centigrade, Celsius. Cannot be water. Water will be frozen. Water freezes at 0 degrees. This is minus 70 there. What is it? It's methane gas. Methane, which is gas and room temperature here on Earth, when you cool it down to 150, 170 degrees, it becomes liquid. So it actually rains methane, it snows methane, and there are lakes and rivers of methane on the moon Titan. And that is mind-blowing. It's amazing. We'll learn more details about this later on in the episodes. So, do we do only experiments? Sometimes we just build a model. We don't have to do an experiment. We will build a model to help us visualize and understand more how things work. But we have to be careful. We have to build our model to fit the data, to fit the observations, and not the other way around. In science, models help us visualize how nature perhaps works. But if we discover that the data and if the observations and if the facts of nature, if nature tells us that this model is wrong, what do we do with the model? We throw it away. We discard it, and we build a different model. So the model and the observations have to agree if we have to accept the model. If the observations don't agree with our model, we throw it away, and we build a different model that fits the data and the observations. Unfortunately, a lot of people on Earth today, they want to fit the universe to their model. They have a certain idea of how the world works, and they want to fit or change the universe, change the facts to fit their ideas. Science is exactly the opposite. In science, we actually have to build our models, our ideas, our understanding, our facts, based on observation and data. I'll give you an example of how we should interpret these observations, because the interpretation of the data is also very important. Sometimes we may come up with the wrong conclusion if we're not careful. Here's an example. Suppose we say that all trees are green. That's true. In general, everywhere you go, you see that trees are green. That's very good. So someone says, okay, my shirt is green, so my shirt is a tree. Of course not. That's ridiculous. Shirt is not a tree. It's just a shirt. Well, this is an obvious example. It's silly, it's simple, but sometimes it's not so obvious in science. But we use this simple example so we understand the idea or the concept. So someone will say, okay, look, if all trees are green and my shirt is not green, my shirt is green, why isn't my shirt a tree? Explain that to me. So what's the logic? How would you convince someone that a shirt cannot be a tree just because it's green? Well, this is the logic. This is how you do it. You say, look, green, being green can be more than just trees. Many things can be green. We didn't say that everything green is a tree. We said that every tree is green. So other things can be green. A car, or a drink, or a pen, or a chair, or a table, or a shirt can also be green. So green can include many things within it. Trees are just part of the domain, we call the domain of being green. And this green shirt is only part of this domain of being green. Okay? So the interpretation of the data, the logic that we use to come up with conclusions about the universe and about the facts of nature is important. And I use this example to illustrate the point. Of course, it's silly, but it illustrates the point very nicely. So, this is our first episode. I would like you to come and join me and learn more about the other episodes and enjoy this fantastic and mind-blowing and amazing journey to learn about nature and the natural world. Next episode is called Marching for Science, and I hope you join me. Thank you for your attention, and please subscribe and tell your friends about this so that we have a lot of people learning about these amazing things. And see you next time.